If you knelt at the edge of a forest path and pressed your hand to the cool dark earth, you would be touching the surface of one of the most populous, most intricate, and most quietly busy ecosystems on the planet, a world we walk on every day and almost never see. The soil beneath your hand is not a simple, lifeless substance. It is a city, a slow, dim, layered city, in which more living creatures move and breathe and feed than in any rainforest canopy above it. A single teaspoon of healthy garden soil holds, on average, more microorganisms than there are people on the entire earth. Billions of bacteria. Hundreds of millions of fungi. Tens of thousands of tiny creatures called protozoa, single-celled, blind, ancient. A small army of nematodes, transparent thread-like worms small enough to swim through the films of water that cling between grains of sand. And these are only the smallest residents. The teaspoon also holds, somewhere in its cool dark, the tunnels of mites, the burrows of springtails, the hair-thin roots of unseen plants, the slow chemistry of decay and renewal. We so rarely think of the soil this way. We speak of it as if it were simply dirt. As something to be cleaned off our hands and shoes, swept from our floors, scrubbed from our windows. And yet, without it, almost nothing on the surface of this planet would be alive. Forests, fields, prairies, even the great sea, all depend, in one quiet way or another, on the slow-living work of the soil beneath them. The soil is built, very slowly, from the patient breakdown. In a mature forest soil, the layers are easy to read, if you know how to look. At the top, there is a soft mat of fallen leaves, twigs, and seeds, still recognizable. Beneath that, the leaves have begun to darken and break apart, their veins still visible but their bodies turning into something between leaf and earth. Beneath that, a black crumbling humus, made of leaves and stems so broken down that you can no longer tell what they were. And beneath the humus, the mineral soil itself, dark with the slow infiltration of nutrients, threaded with fine pale roots and the white whispering filaments of fungi. Those fungi are perhaps the most surprising of the soil's residents. We see them, when we see them at all, only in the brief mushrooms that push up after rain. But a mushroom is only the fruit of the fungus, the way an apple is only the fruit of a tree. The body of the fungus lives beneath the soil, in a vast network of thin white threads called hyphae. A single mushroom on the forest floor may be the visible tip of an underground organism that stretches for many acres. The largest known living organism on Earth, in fact, is not a whale, not a redwood, but a fungus, a single individual honey fungus growing in the soil of an Oregon forest, covering roughly 3.5 square miles, and quietly estimated to be somewhere between 2,000 and 8,000 years old. The roles these fungi play in the soil are slow and enormous. They are the great recyclers. They are the chemists who break apart the tough fibers of fallen wood and return them, atom by atom, to the living world. Without them, the forests would slowly choke on their own fallen debris. Within them, every leaf that falls is, in time, returned to the air as a slow exhalation of carbon, or to the trees as a fresh supply of nutrients. Even more remarkable is what happens between fungi and the roots of living trees. In a healthy forest, the roots of nearly every tree are interlaced, microscopically, with the threads of certain fungi. The fungus wraps itself around the tree's smallest root tips, and the two creatures form a quiet partnership, a mycorrhiza, the soil scientists call it. The fungus brings the tree water, and rare nutrients, and minerals it could not reach on its own. The tree gives the fungus sugars, made in the leaves above, through photosynthesis. And because each fungus is connected to many trees, and each tree to many fungi, the soil beneath a forest is a vast quiet network. Sugars from a sunny tree on a hilltop have been measured moving, through fungal threads, to a shaded sapling far down the slope. Warning chemicals, produced by a tree under attack by insects, have been measured traveling through the same threads to neighbors that, when alerted, begin to produce their own defenses. The forest, in this sense, is not a collection of separate trees standing next to each other. It is a single great cooperating creature, with most of its working life hidden underground. If you could shrink yourself to the size of a grain of sand and step down into the soil, you would find yourself in an almost lightless world. The air would be cool and humid. The walls of the small spaces around you would be smooth in places and rough in others, mineral particles glued together by the slow secretions of bacteria. Films of water would coat every surface, and in those thin watery films, a slow traffic of life would be moving, bacteria drifting in their millions, single-celled protozoa hunting them like microscopic whales, nematodes gliding through narrower passages, all of them feeding, dividing, dying, decaying, being eaten in turn. You would find rooms of pure air, where the rain had not yet reached, and rooms full of water, where the rain still remained. You would find sudden tunnels, the work of earthworms, far wider than your shrunken body, leading down into dark depths. The earthworms are some of the great architects of the soil. They eat the soil itself, passing it through their long bodies, breaking down the organic material in their guts, and excreting it as the rich dark castings that gardeners prize. A single acre of healthy meadow can hold more than 1 million earthworms. In a year, those earthworms will move several tons of soil up to the surface, slowly turning the field over, on a timescale so patient that we do not notice it happening. Charles Darwin, in the last book he wrote, spent more than 400 quiet pages thinking about earthworms. He was fascinated by them. He measured how much earth they moved. He documented how ancient Roman ruins had been slowly buried by their patient labor. He watched them in glass jars in his study, recording their preferences and their sensitivities. He came to believe that the entire surface of the earth, in any place where worms lived, had passed through their bodies many times in the long, slow history of the world. The dirt beneath your feet, he wrote, has been a guest, many times over, in the gentle dark of a worm's gut. There are creatures in the soil that we still know very little about. Tardigrades, the tiny 8-legged creatures sometimes called water bears, live in the films of moisture between soil grains. They are nearly indestructible. They can survive boiling, freezing, the vacuum of space, doses of radiation that would destroy almost any other creature. When the world dries around them, they curl into a small, almost lifeless cyst, and wait, sometimes for decades, until water returns. Then they unfold themselves, and continue, as if no time had passed at all. There are mites in the soil so strange they look like designs from another world. Some are armored, like miniature knights. Some are translucent and pale, with long delicate legs and bristled mouths. Some live their entire lives in the body of a single decaying leaf, born and dying within an inch of where they began. And there are the springtails, tiny 6-legged creatures with a small tail-like spring tucked beneath their bodies, which they release when threatened, sending themselves several inches up into the sudden bright air, before settling back into the safe dark of the soil. Above all this, and intertwined with all of it, the great pale network of fungi continues to grow and feed in exchange. The roots of grasses reach down. The roots of trees reach further still. The slow chemistry of decay continues. Old leaves become humus. Humus becomes mineral soil. Mineral soil becomes the food of grass. The grass becomes the food of the deer. The deer becomes the food of the wolf. The wolf, in time, becomes again the food of the soil. Every story of every life on the surface of this planet circles back, eventually, to the dark patient kitchen beneath. In all of this hidden traffic, perhaps the most quietly important work is the work of the bacteria. They are the smallest residents, but they are also the most numerous, and the most chemically inventive. Some bacteria pull nitrogen from the air, which no plant can use directly, and bind it into compounds the plants can drink up through their roots. Without them, almost no agriculture would be possible. Some bacteria specialize in the breakdown of certain woody compounds, some in the recycling of phosphorus, some in the patient work of cleansing the soil of certain toxins, slowly converting them into harmless materials. Every shovelful of healthy soil is a small chemical city, with thousands of specialists each doing the slow work they have evolved to do. Healthy soil is also, gently, alive in time. It remembers. The earth on which a forest stood for centuries holds a different chemistry, a different community of microbes, a different texture than the earth on which a field has been plowed for 100 years. Bacteria and fungi remember the plants they grew up beside. Earthworms remember the leaves they have processed. Even the small mineral grains carry, in their slow weathering, the history of the rains that have fallen on them. Soil is, in this sense, one of the great memories of the earth. To dig into it is to dig into time. When you next walk through a forest, or along a meadow path, or even across a quiet patch of grass beside a city street, you can take a moment to imagine the slow city beneath your feet. The pale threads of fungi, threading across the dark. The patient earthworms moving the soil one grain at a time. The bacteria, in their billions, doing the slow chemistry that keeps the meadow alive. The mites and springtails and nematodes pursuing their tiny lives in tiny rooms. The roots of every plant above you reaching down through the cool quiet, drinking the slow patient work of all of those creatures. You do not need to see them. They will do their work whether or not you are watching. But there is something gentle in knowing that they are there. In knowing that the world is, beneath its quiet surfaces, full of slow, intricate, ancient life. In knowing that the dust on your boots may have passed through the body of an earthworm many times over, that the pale threads of a single fungus stretched out beneath the trees you love may be older than the language you are speaking now, that the soil itself is busy with the slow, gentle, patient work of holding everything alive. The quiet world beneath the soil is one of the great unnoticed marvels of this planet. It does its work in the dark, without praise, without rest, on a timescale older than civilization. And it is doing that work now, gently and steadily, beneath every leaf, beneath every footstep, beneath every quiet place where life has chosen to root itself in the slow patient memory of the earth. Consider how the soil came to be in the first place. For most of the Earth's long early history, there was no soil at all. The continents were bare stone, scoured by wind and rain. There were no plants. There were no fungi. There were not yet any small soft-bodied creatures to add their bodies to the mineral dust. The world was beautiful but empty in a way we can hardly imagine. Soil, in the rich modern sense, did not begin to appear until life itself had moved out of the seas and onto the land. It took the slow patient cooperation of mosses, fungi, lichens, and the first humble plants, working together for many millions of years, to begin building the dark living crust that now covers so much of the world. In a sense, then, the soil is not a separate thing from life. It is a record of life. It is the slow accumulation, over geological ages, of every leaf that has fallen, every root that has died, every creature that has lain down for the last time in the open air. The soil is where life keeps its memory. Every handful you pick up holds the bodies of plants and animals you would never recognize, all returned now to the deep gentle democracy of dust. Different parts of the world have grown different soils. In the cool wet north, where pines and spruces drop their needles in slow patient layers, the soil is acidic and dark, often holding only a thin band of organic matter above a pale mineral layer leached by centuries of slow rain. In the warm dry south, where grasses grow tall and fires sweep across the plains, the soils are rich and deep, sometimes black for many feet beneath the surface, holding the carbon of countless seasons of grass. In the tropics, where everything decays so quickly that nothing has time to gather, the soils are surprisingly thin and fragile, and the great forests above them sustain themselves more on the cycling of fallen leaves than on the soil itself. In the deserts, where rains are rare, the soils are pale and dusty, and yet even here, a thin living crust of bacteria, algae, and lichens binds the surface and prepares the way for what little life can take root. There are also places on Earth where the soil has been forming for so long, undisturbed, that it has developed into structures of astonishing complexity. The deep black soils of the American Midwest, the Chernozems of Ukraine, the Terra Rosa of the Mediterranean, all hold within them the patient archive of thousands of years of plant life. To plow such soils is to disturb a long quiet history. To care for them is to take part in something far older than oneself. In some parts of the Amazon, indigenous peoples noticed centuries ago that certain patches of the rainforest grew with extraordinary vigor. The soil in those patches was darker, richer, more fertile than the thin, pale soils around them. We now know that this dark earth, called terra preta in Portuguese, was made by the patient hands of ancient peoples, who added charcoal, broken pottery, bone, and the slow leavings of their cooking fires to the soil over generations. The charcoal in particular gave the soil a structure that held nutrients and water for the centuries that followed. Today, even after long abandonment, terra preta soils are still rich. They are a quiet gift from the people of the past, and a reminder that the soil remembers what we add to it, both in damage and in care. The soil also keeps temperature in a slow, patient way. The air above the ground may swing through wild changes between morning and night, between summer and winter, but only a few feet down, the soil holds a steady cool. This is why so many creatures, from earthworms to bears, have learned to spend the hard seasons of the year underground. The soil is a shelter against extremes. It buffers the world against the worst of its own weather. And when you breathe in, on a quiet summer afternoon, the smell of damp earth that rises after a rain is itself a slow-living thing. That smell, sometimes called petrichor, is partly the work of a soil bacterium called streptomyces, which releases a compound named geosmin as it lives and dies. Human noses are extraordinarily sensitive to this scent. We can detect just a few parts per trillion of it in the air. There is something deep in our species that is tuned to the smell of soil that has been touched by rain. Some scientists think this sensitivity may have helped our ancestors find water in dry seasons, by following the scent of wet earth across the savanna. We are, in some quiet evolutionary way, a creature that knows when the soil is breathing. Even the smallest seeds in your hand carry within them a long argument with the soil. A seed will wait, sometimes for years, for exactly the right combination of moisture, warmth, and small chemical signals from the surrounding earth before it will agree to sprout. Some seeds need to pass through the body of an animal, where the chemistry of the gut wears down their tough outer coat. Some need to feel the long cold of a winter, so they know they are no longer in the wrong season. Some need fire, the brief intense heat of a passing wildfire, before they will open. The soil is in conversation with every seed it holds. The seed listens. The soil answers. And in time, when the answer is right, a small green shoot pushes upward, and the slow story of another plant begins. All of this is happening, this very moment, beneath the meadows and the forests and the parks and the gardens of the world. The slow-living chemistry. The patient drift of microscopic creatures through their thin films of water. The pale fungi reaching across acres of darkness. The seeds waiting, in their quiet listening. The earthworms moving the soil up to the surface, one grain at a time. The bacteria binding nitrogen out of the air. The roots reaching, gently, downward. The leaves above, falling, slowly, to begin the long return.